Hassler here. I'm going to go ahead and give you the notes for 5.3. There's some new vocabulary in 5.3, and then we're going to do some practice with that vocabulary. And so the first vocabulary piece that we had talked about as we were working through the lesson in class was called domain. And domain deals with all of the values of x that the function uses. So we're going to say all values of x the function uses. Except I can't spell uses, my apologies. And so what we had talked about in class, the graph that we had in class, took a look at there we go. It was actually kind of similar to this graph that we have here, this example over here. And we could say that, hey, there's an x value of -4 that gets a point associated with it, and an x value of -3, a point associated with that, and -2 and -1 and 0 and so on. But technically, I have these little black lines in between each of those points, and each of the numbers between -4 and -3 have points that get plotted to create that line. So technically with this continuous line, this stretch of my curve here, every single x value that is on the number line between -4 and it looks like 8, every single number, decimals, fractions, positive, negatives, between -4 and 8 are going to have a point that gets plotted to create this graph. And so instead of listing, because I cannot list every single number between -4 and 8, if I'm thinking about every decimal that gets used, we write this inequality. And the inequality that we use looks like this. So it's going to be some number less than or equal to x less than or equal to some number. And the numbers that are going to go in these lines is either going to be the smallest x value, because that number is less than or equal to or smaller than or equal to every single x on this interval, right? So in other words, -4 in this case is the smallest x value, and it is smaller than every single x value in between -4 and 8. And so sometimes what I like to do is I like to kind of put these barriers between at my endpoints, right? So every x value between these blue barriers, -4 and 8, are going to get used. And all the numbers in between those barriers, all those x's, are smaller than or equal to the biggest x value. And so it's like we're saying that we're looking at all x's between blank and blank. That's what we're looking at, okay? The other thing we talked about then was range. And range is extremely similar, except range looks at all the y values. So range is all values of y the function uses. And so again, I'm going to come in, we'll do green, right? So now I'm looking at the y-axis, which means I'm looking from bottom to top. So bottom of my graph, the lowest y value here that gets graphed is 1. And the highest y value that gets graphed here is 7. So every single y value between 1 and 7 has a point associated with it, right? So this y value of 5 has a point plotted with it. And this y value of 3 actually has 2 points plotted with it. And everything in between, all numbers between 1 and 7 have a number plotted in terms of the y coordinate. All of the decimals even, okay? And so again, we have this same setup. We're saying some number less than or equal to y, because we're looking at range, all the y values, less than or equal to some other number. And again, we're looking at the smallest y value and the biggest y value. In other words, I'm looking at all y between blank and blank. And again, I'm picking a y value that this is the smallest y value because that y value is less than or equal to every other y value trapped in that interval, and all of those y values in that interval are smaller than or equal to that biggest y value. And so we have domain and range as these new ideas. All right, so I want to go through and I want to answer some of these questions over here. F of 2. So f and g are two different functions. My table is the f function and my graph is the g function. So f of 2 is an input. And so when the input is 2, the output is 1. G of 2 is an input or an x value. And so when g is 2, the y value that goes with is 5. So that's review of what we've been doing. Which function has a greater y-intercept? So I'm just going to make a note to myself. A y-intercept occurs when x is 0. And so what I'm going to do is I'm going to figure out what f of 0 is. And again, I'm looking at my table. F of 0 is 7. And I got to figure out what my y-intercept is for my graph. My y-intercept is where I cross the y-axis when x is 0. My output is 1. So which function has the greater y-intercept? My answer is f. F has a greater y-intercept. And if it were to say, how do you know? This is my evidence. I'm showing you what the two outputs are so that I can show or prove to you that I've made the right decision. 7 is clearly larger than 1. D says, if g of a equals 6, what is the value of a? Okay, well, this time, 6 is the output. So I'm looking for the input. I'm looking at the g function. So when g has an output of 7, that's right here. I'm looking for the x that goes with it, and the x that goes with it, or that specific a value, is 8. And then this says state the domain and range, which is what we talked about in the notes in the box next to us. And so the domain are between these blue boxes, right? All the x values between my lowest x value that's graphed, -4, that's less than or equal to all of the other x values, which is less than or equal to 8. So all x values between -4 and 8. If you just said -4, 8, that would be incorrect. -4, 8 looks like an ordered pair, and we are actually wanting to include every number that's between -4 and 8. My range deals with all the y values that get used, and we said that was all the numbers between these green barriers, right? I'm looking from bottom to top on the y-axis. The smallest y value that has a point associated with it is 1. That's less than or equal to all the other y values, which is less than or equal to 7, the biggest y value that got graphed. Okay, so now your job is to go to try the 5.3 practices. There is a practice A and a practice B. Those will be assigned on different days, so just make sure that you're paying attention to Google Classroom. If you have questions, let me know.